In this video, we're going to look at the problem of coset addition and show that it is well defined for any ring and any subring. In other words, we're going to let R be a ring, and S is any subring of R. And we're going to define A plus S added to the coset B plus S to be the coset A plus B plus S. And what we want to do is we want to show that this operation is well defined on the set of cosets, which is R mod S. Now, in order to do that, what we basically have to do is we have to have two names for both of the two cosets that we're adding together. In other words, we're going to let A1 plus S be equal to A2 plus S, and we're also going to let B1 plus S be B2 plus S. Now, the top one tells us that A1 minus A2 belongs to S. In other words, we can write A1 minus A2 is equal to some little s1 inside the subring S. And our second equation is going to tell us that B1 minus B2 belongs to S, which is the same thing as being able to say that B1 minus B2 is equal to some little s2 belonging to S. And our question is going to be, are the sets A1 plus S plus B1 plus S, which is A1 plus B1 plus S, and the set A2 plus S plus B2 plus S, which is A2 plus B2, there should be a 1 there, plus S, are these two sets equal? And in order to investigate that, what we basically need to do is we need to look at the representative of the first set and the representative of the second set and see if their difference lies inside the subring. So in other words, we're going to look at this. I'm going to look at A1 plus B1, and I'm going to subtract off A2 minus B2, plus B2. So we're looking at this representative minus that representative. But if we are in the ring R, and so this boils down to A1 plus B1 minus A2 minus B2 by the law of signs in the ring R, and we can always put parentheses, well, we can rearrange things. Let's see, that's not what I want. So we can rearrange things and rewrite this as A1 minus A2 plus B1 minus B2 because this is in R and plus is commutative. So this is because plus is commutative inside R. And now we can put parentheses around that pair and that pair. And I want to remind you that we know that A1 minus A2 is equal to S1, B1 minus B2 is equal to S2. So we substitute, and we've got that this is S1 minus S1 plus S2, and that has to live inside S because S is a subring. And since A1 plus B1 minus A2 plus B2 does indeed belong to the subring, that tells us that A1 plus B1 plus S is equal to A2 plus B2 plus S, and that's enough to say that our addition is well defined on the set of cosets of S.